Alright, so when you have variables on both sides, you're going to sometimes get one solution, just like every other equation that we've ever solved, we always get one answer. However, sometimes you'll get things that have infinite solutions, and sometimes you'll get things that have no solution. So we'll talk about those possibilities as well. But I'm going to start off with equations that have one solution, because those are going to be more familiar to you. So when you're solving these equations, the very first thing that you need to do, just like we did before, is if you can distribute, you want to distribute. So if you see parentheses in your equation, you know that you need to distribute, and that has to be first. The second thing that you want to do, if you can, is combine like terms. So far, everything is just like we have been doing. So you don't want any more than 2 terms on each side of your equation. Each side of equation should have no more than 2 terms. You'll have a term that has your variable, and you'll have a term that has your constant. It's possible that you just have 1 term, but you don't want 3 terms, 4 terms, 5 terms, etc. If you have more than 2 terms, that means that there are things that you can combine. Tommy, question? Yes, that's the no solution, all solution thing I just mentioned. Ethan? Two different numbers that have 2 different constants. Do you mean variables maybe? You're not going to have more than 1 variable. You'll have the same letter. So it's not like you're going to have an x and a y in the same equation. Okay, you'll just have an x only or a y only. Okay, good question. All right, now this step is going to be a little bit different. So we're going to have a variable on both sides of the equal sign. We are going to get rid of, and by get rid of I mean we're going to do the inverse operation of the variable that is on the right. So I'm going to say in parentheses, or in quotes, get rid of variable on right. And then you'll solve. And we are going to do plenty of examples, but I wanted you to have these steps at the top of your notes so that you can refer back to them. All right, let's go ahead and start solving some. So let's say I have 6n plus 5 plus 5n equals n plus 3 plus 8n plus 14. Looks horrible. Before I do anything, I'm just going to make sure everyone has time to write it down. Another strategy that you could have on any of these equations, sometimes it's helpful for people to kind of make like an imaginary line down through their equal sign, and it just keeps those 2 halves separated. So our first step is to distribute if we can. Can we distribute in this problem? No, we don't have any parentheses, so that means we get to move on to step 2, which is combining like terms. Obviously, I have more than 2 terms on the left, and I have more than 2 terms on the right, so there are things that I need to combine. So on this left-hand side, I'm going to combine my 6n and my 5n, and that's going to give me 11n. And then there's nothing to combine with this 5, so it stays a 5. Put my equal sign down. And now I'm going to look on the other side of my equation. I have an n, and an 8n. That gives me 9n. And then I have a 3 and a 14. That gives me 17. So notice I can only combine things on the left with other things on the left. I can only combine things on the right with other things on the right. So that invisible barrier, I can't combine things that are on two different sides of the equal sign. All right, so now we're at the step where we haven't done yet this year, and that is we have an n on the left and we have an n on the right. So that third step that we just wrote down in your notes is get rid of the variable that's on the right. So how would I get rid of a positive 9n? You got it. I'm going to subtract 9n from both sides of my equation. Now, which one of these terms would I subtract it from? Because they're like terms. Very good. So 11n minus 9n gives me 2n. Nothing changed about my 5. Nothing changed about my equal sign being there. 9n and 9n minus 9n, well, that's 0, so that's gone. And I have my positive 17 left. So now you just solve it. Okay? So what do I do to solve this? All right, minus 5. So that gives me 2n equals 12. So n equals, good. You don't think what? Well, there's more. There's more to it. So he's like, oh, this is easy. Right. Well, I mean, there are more things to it than just what we just did. Because before we started, I say there's equations that have one solution. So this equation has one solution, but there are also equations that have no solution and infinite solutions, or all solutions. So we want to have some examples of those too. All right. Let's do this one real quick, though, before we get into other things. And I'm going to have you do this one on your own, okay? Try it on your own. Okay, so the first thing you should have done, since there are parentheses we need to distribute, so 3 times negative 2x is a negative 6x. 3 times a positive 5 is a positive 15. Nothing changed about what's over here. There are no terms that I can combine on the left or the right, so I don't have to combine any like terms in this one. So I'm going to move on to getting rid of the variable that is on the right. This is not just 4x, but this is a negative or a minus 4x. So I'm going to add 4x to both sides. Now, the only term that I can add 4x to is my negative 6x. So negative 6 plus 4 is a negative 2x. My 15 did not change. And my 11 did not change. These crossed each other out. So now I have this. Any questions before? Because I know after this it's easy. We okay on what I did? Okay. So then I'm going to subtract 15. So negative 2x equals negative 4. So that means x equals 2. Now, since we're at this point in the equations, if you're someone that's really good at solving them once you get to this point, I don't care so much about you showing your work anymore on these 2 steps. Okay? So once you get to it's 2 steps left, just solve it. Tell me. Okay, next problem. Two plus 5w equals 2w plus 2 plus 3w. Can I distribute? No. Can I combine like terms? Yes. So let's combine like terms. I have a 2w that can combine with a 3w. And then I don't have anything that can combine with that. So it's by itself. Anyone notice anything? What? So they're exactly the same. Do you notice that the terms on each side are exactly the same? I know they're in a different order, but I have a positive 2 on both sides, and I have a positive 5w on both sides. So exactly the same. What would happen if I subtract 5w, like that's my next step, is to get rid of this one over here. Well, when I do it over here, it's going to get rid of that one too. So what I'm going to end up with is 2 equals 2. So basically what this is saying is you could put any number you wanted, any number, and replace that in for the w, and it would work. W can be anything. Are you bringing it back? So the answer is sometimes you'll see all solutions, and other times you'll see infinite solutions, but it means the same thing, okay? So I want you to hear both of those terms, infinite solutions, because just depending on who's writing the question, sometimes they'll give you the option of saying all solutions, sometimes they give you the option of infinite solutions. It means the same thing, okay? No, they're not going to give you both. They'll give you one or the other. So again, when they're exactly the same, it's all solutions. And they're never going to, you're always going to have to do something. Like, you're not going to be able to look at it before you do anything and say, oh, they're the same. You'll either have to combine like terms or you'll have to distribute. But then once you've combined like terms and distributed, then you'll realize, oh, they're exactly the same. Now the other option is this. Give you a second to write that down before I start talking about it. Okay, so I'm going to start distributing. So over here, distributing your negative 3. Negative 3 times 8x is a negative 24x. Negative 3 times positive 11 is a negative 33. On my other side of the equal sign, I have 6 times negative 4x, which is negative 24x, and 6 times negative 13, which is a negative, thank you. Now, do you notice anything about this one? What do you notice, Tommy? But different constants. So in the last problem we just did, you had the same term, the term that had the variable was exactly the same, and the constant was the same. In this one, the term with the variable is the same, but the constants are different, okay? So you could say something like, these are the same, yet these are different. So the constants being different doesn't, if the constants are different, they're different. Okay, now this matters. I don't want you to see negative 24x over here and a positive 24x over here and be, oh, they're the same. A negative and a positive are not the same. Okay, so keep that in mind. Because what happens is, if I were like, okay, I'm going to solve this to get rid of negative 24x, I'm going to add 24x, add 24x. Well, that's gone, and I get negative 33. Over here, that's gone, and I get negative 78. Negative 33 doesn't equal negative 78, so that's impossible. So the answer would be no solution. There is no number in the world that you could put in there for the x that would work. Okay? So when you get your assignment, there's 10 problems. You're either going to solve it and be able to get just one final answer, one solution, or you're going to realize they're exactly the same on both sides, so it's all solutions, or it'll be like this one, where you have the term with the variable the same, but the constant's different, and it's no solution. All right, so I'm going to give you time to work now so that